Welcome back, everyone. In this lecture, we're going to focus on the deployment aspect of connecting our model to some front-end HTML. That way, any user, whether or not they're technical, can just go to this website and then feed in their data and actually get back a prediction. So we're going to focus again on connecting that Flask app and the TensorFlow model to an HTML form so any user can interact with the model. Please note that in order to fully understand this section, you do need to have a basic understanding of HTML and Jinja templates. If you don't have an understanding of that, I would highly suggest you go take a web development course first, maybe a Flask course, and then come back to this series of lectures. Okay, so let's talk about what this actually requires. We're going to need our application, which we already have as myexample.py. We're going to need to add a few things to it in order to connect it to, underneath a template folder, we'll have two HTML files, home HTML and prediction HTML. So we add a couple of things to the application to connect to those templates. Let's talk about each of these aspects. For the application, main thing we're going to add here is connecting it to HTML files. And that involves using Flask to create an HTML form and inject that HTML form into the home.html page. Then we'll use Flask to accept submitted HTML form data. Then we feed that data to our model, and then we'll use Flask to return the prediction to a new page, prediction.html, which once a person hits submit on home.html, it takes them to prediction.html. The home HTML is a very simple HTML file that uses a Flask-based form to accept user input. And then it sends this input back to the Flask app for processing with the return prediction function. The prediction.html file simply returns back the prediction information once that prediction function has completed running. Now make sure to use our files as a reference. I should really make it clear that it's extremely easy to make just even a simple typo, such as an extra space, that can break all the connections here. So we're dealing with a lot of different file types, so make sure to use our files as a reference in case you get an error along the way. All right, let's get started. What we're going to do is head back to that myexample.py file that we've been playing around with. Okay, here we are at myexample.py. Recall, currently our myexample.py has our return prediction function, and it has essentially two routes, a home page and an API page. However, these are not actually full HTML pages. Instead, what they do is the prediction page just returns JSON, and the home page for routing just has a single heading of Flask app is running. What we want to do is eventually connect both of these to some actual HTML files. To do that, we first need to do a couple of things. We no longer need request or JSONify in order for this to work because we're not actually accepting JSON requests. Instead, we're feeding in from an HTML form. But that does require a couple of more imports from Flask. What we need to do is get render_template, which actually renders an HTML template. We'll still need session in order to grab session data, and then we'll say URL4, which connects to different URLs, and that's it. The next thing we want to do is we'll be using a Flask library called WTF Forms, which is just a very simple library for creating forms quickly with Flask. So we'll be using that to essentially inject the form with Jinja templating, and we'll say from WTForms, WTForms, import, and we'll have two fields. We'll have a text field and a submit field. And we'll see later on how we actually use these. Essentially, a text field, we're going to have 4 empty boxes of text that the user can type in their measurements to, and then submit field is just a submit button. Okay, so we have those ready to go. Next, what we're going to do is we will scroll down here. We have our Flask application. In order to correctly actually get form information, what we need to do is set up a secret key. So after you create your application, say app.config, and then in quotes and in all caps, you say secret_key. And then we set that to just an arbitrary string. So we'll say my secret key. This is typically an environment variable, but for right now, we're just setting it within the application. Okay, so this secret key basically allows the forms to work. It essentially makes sure that it's not being hacked, so to speak, and that the person filling out the form is actually the person that should be viewing the next page. Okay, next, what we need to do is create a class, and you could, if you want, separate this out into multiple .py files, but we're putting it all in the same py file. It's for simplicity of filming. But what we want to do is create a form class. So we'll say flower form. And then what we need to do is actually grab a Flask form. So if we come back up here, we're going to do one last import, which is import Flask underscore WTF. And in fact, instead of importing Flask, we'll just say from Flask underscore WTF, import the Flask form. Okay, so that allows us to then inherit that form class. So we'll scroll down here back to flower form, inherit Flask form. And Flask form is our basic form class that's built into this WTF forms library. And here what we're going to do is construct a form. So there's 4 things we need to collect, and that's sepal length. So we'll create a text field, and then here we'll give it the label of sepal length. The next thing is sepal width. Create another text field, and that will say sepal width. Last one, or last 2, is petal length. Again, similarly, just a text field with petal length. And then we have petal width, which is also just a text field. And this will say petal width. So what we're doing here is we're using this Flask form library to create a form of 4 text fields. The text field is something that the user will then later on see in the HTML page, and there'll be 4 text fields that the input sepal length, sepal width, petal length, and petal width. Finally, to finish off a form, you need a submit button. So we say submit is equal to submit field, and here you can just type in submit or whatever you want the submit button to say. We'll go ahead and have it say analyze. You can also have it say predict. And that's all we need for our form. Okay, next is our actual home page right now. Right now our home page is just returning back the raw HTML code of Flask app is running. What we want to do is change this to actually be the form. So what I'll do here is I'll delete this return line and start building out my index. So the first thing I need to do inside this index is say form is equal to an instance of flower form. So this creates an instance of the form, and then if the form, and we'll say dot validate underscore on submit, it basically makes sure that you're actually submitting text in those form, then we're actually going to grab data from it. So we'll say session, and we'll start saving things to the current session. So we'll say form dot sepal underscore length dot data. And we're going to do this for all 4 objects. So what are we actually doing here? We're creating an instance of the flower form class, which recall we just created up here. And what the flower form class does, it essentially has these 4 attributes, really 5, but the main attributes are sepal length, sepal width, petal length, and petal width, which are obtained from these text fields. So after creating that Flask form, what we're doing is we're saying from that form, grab that sepal length attribute and grab the data, which is just the text. And then we're going to essentially copy and paste this 4 times because we're doing this for not just the sepal length, but also the sepal width. So change this to also width. And then we're also doing it for petal length. So pet len, and then we're also doing it for petal width. So we'll change this right here to pet underscore wid. In order to make sure this form can actually work, we need to make sure that the methods on this actual page are both get and post. We should be able to actually go back and forth with this form, which means under here, under route, what we want to say is methods is equal to, and then pass in a list of both get and post methods. And that will allow our form to successfully get information from the user and then post new information either on the same page or on a different page. Okay, once the user has submitted the form and it's valid, so if form.validate on submit is true, we grab all that data, save it to the session, and the session is basically this dictionary-like object. Then we'll say return, and we will redirect to URL underscore 4, and then we'll just pass in the string code prediction. Okay, and we'll see where prediction comes from in just a second. this redirect and this URL for functionality, that comes from all the way up here. We have URL for. Redirect will also need to be imported. So we'll say import redirect from Flask as well. Okay, so we've done those imports. Let's come back down here. And let's say this is only when the form is submitted. We actually need to show something on the home page before they start submitting the form, which means I should, in line with this if statement, say return render template. And here's where we'll say home.html. Make sure we spell that right. And we say form is equal to form. Okay, and that's it for our home page view. So what's actually happening here? I created the home page. On the home page, I create this new flower form, which is this WTF form from Flask with 4 text fields and a submit button. And then if the form is valid, once that user hits the submit button, I grab all those text data points and save them to my current session. The session essentially is a session object for the user that behaves like a dictionary, and then we'll redirect for prediction. And then I have this render template, which renders home.html. So I only redirect them if the form is validated upon submission. So notice I use this string code for prediction. That means for my other view here of app.routing, what I need to do is change this to just be prediction here. That way it can connect to this URL for. And I'll also change just the actual routing to be prediction. And I don't need any methods here since there's no form and no data is going to be accepted here. So what does prediction actually look like? It's a pretty straightforward, I should say. I'm going to delete this. The content essentially now starts off as just an empty dictionary. And then I'm going to say content of sepal_length is equal to the session data for sepal length. But recall that these are text fields, so I need to convert them to floats in order to pass this in as what is essentially a dictionary or JSON object to my return prediction function. So then let's do this 3 more times. We'll go ahead and copy this, paste that in, and then we do that not just for sepal length, but also for sepal width, and not just for sepals, but also the petals as well. So I'm changing all these guys to match up the session data before. And then this content, these key codes need to match up what, if we scroll up here, this sample JSON expects from the return prediction function. So these are all being connected here. And I would encourage you to pause if needed. I know there's a lot going on here, but a lot of it's just repeated code. Okay, and then we'll say petal, and then this last one should be petal width. So close this off, petal_width. Okay, so we have this empty content dictionary, and then what I do is I set up the content dictionary for my return prediction function, and I grab all this session information and cast it as floats. And then finally, I'll say results is equal to return prediction, where my model is the flower model I loaded. Then I have my flower scalar, and now my sample JSON is just the content that I created. Once that's done, I'm going to return render template, and I'll render a prediction.html file where results is equal to results. And that means results is something I can use within the prediction.html. Now the next thing we need to do is connect prediction.html to the prediction function routing, and then home.html to this index routing. So how do we actually do that? Well, we actually have HTML files already prepared for you, and instead of kind of coding out because they're really repetitive, we're just going to show you what they are and how they connect to each of these HTMLs. So what I will do is I will say file, open file, and underneath deployment, what I'm going to do is open underneath templates folder, home and prediction. So go ahead and select both of those and open them up. And here we have what the home HTML looks like and what the prediction.html looks like. Something to note here is that they need to be located under a folder called templates, all lowercase. Flask, by default, looks for a folder called templates to find the HTML files that the routing functions refer to. So if you're not familiar with Flask, That's kind of really common. Even in Django, that's common, where the folder has to be called all_templates and all your HTML files go there. So what does the home HTML file looks like? It looks like it says Flask app running, and then it says please enter your flower measurements below. And then we create an HTML form. However, notice that we have essentially kind of two main things for each entry. We have the form, the actual name of that element in the form, and then label, and then the form element itself. So this directly connects to, if we go back to the index, right here we say SEP_len, that grabs the session data from form.SEP_len, which was defined up here as an attribute SEP_len, which is what's being created on this homepage of form.SEP_len. And these double braces is essentially Jinja templating. So notice we have this instance of the form. The way form actually comes to be is that we pass back form is equal to form. And then these actual attribute calls are coming directly from the Flask form object here, where we created these attributes of sep length, sep width, etc. The one thing to notice is there is a hidden tag, and this is the CSRF security feature, which if you're familiar with web apps and forms, most forms need that CSRF security feature in order to work, which is partially the same reason we set up this secret key in order for the Flask form not to give an error or a security error. And at the end, we have the form submit button. So you can imagine you could just copy and paste this for as many entries as you needed, where you have the label, which is just this string code right here in the text field, and then the actual entry itself. Okay, so don't forget to put method post. That's the home page. The prediction page is even simpler. We'll go ahead and return back all the items from the session, saying here's the information you gave, sepal length, sepal width, petal length, and petal width, and then your predicted flower cast is results. Notice the double braces there. Results is being returned directly from, if we scroll back down here, prediction, it returns back these results. Okay, so that's the connection between home.html to the index function and prediction.html to the prediction function. Go ahead and make sure you save all these changes, and let's run this website. To do this, I'm going to open up my Anaconda prompt. I'm going to make sure to activate my environment. We'll say conda activate, and then activate your TensorFlow environment, whatever you happen to call it. We'll say TF2 GPU for me. Once you've activated it, just make sure you have all the libraries installed. You can do pip install Flask, and we also introduced WTF forms, which in case you don't have it in your environment, you simply just need to type pip install and then capital Flask dash WTF. Notice it's a dash, not an underscore. Go ahead and run that. I already have it satisfied, so I'm good to go. Okay, next go ahead and CD to wherever you've saved that file. So for me, it's under TensorFlow 2 Bootcamp under 09, let's go 09 deployment. And then I should be able to type out Python space myexample.py. Go ahead and hit enter. It should load up TensorFlow just as it did before. And then notice now my server is running. Go ahead and open up an instance of your browser. And then you should see something that looks like this. So here is a very simple HTML form with no CSS, no styling or anything, but it should now be able to accept sepal length, sepal width, petal length, and petal width. So let's go ahead and give it some sort of petal to predict from. So I'm just going to make up some numbers here and we'll see what it says. Let's say our sepal length is 5, petal width is 3.5, petal length, let's say 1.5, and then petal width, let's say on this new flower is 0.2. Go ahead and then click the submit button of analyze. And if you did everything correctly, it should then report back the information as a list and say your reported or predicted class was Setosa. All right, all that's left for us is to take this web application and actually deploy it online using some sort of service. In our case, we'll use Heroku since it's free. And that way, any researcher out in the field just needs to have internet access in order to access our deployed TensorFlow model. We'll see you at the next lecture when we do all of this.